Okay, so let's wrap up this page by taking a look at some triangle situations. And again, we're trying to find x. I'll let you go back and actually put the x value in to find the angle values. But to find x here, we're dealing with a right triangle, right? And we know that one of our angles is 90. Another angle measures at 3x minus 5, and the other one's 2x. So basically, to start this one off, we use the fact that we know the sum of the angles needs to equal 180. So that means 2x, right, the angle 2x, plus the angle 3x minus 5, plus 90 would have to be 180. All right, and so that would get everything going because we're using a basic fact about triangles. Of course, to work on this, perhaps we combine like terms. I believe if we combine here, we get 5x minus 5 plus 90 is plus 85 equals 180. We'll subtract 85 from both sides, and I believe we get 5x equals, I think that'll be 95. Divide by 5, and I think we end up with x equals 2. Let's see, goes in once, remainder of 4. 45 is 9. All right, so I believe we would get 19 there. Let me double check myself. 5 and a 9 goes in one time, right? Yeah. All right, so 19 is the x value. Of course, substitute it in 2 times 19. That's a 38-degree angle, and then substitute it there, and you'll find that guy. So there's how we do that, taking advantage of what we know about right triangles, or excuse me, any triangle. The sum of the angles equals 180. E is very similar, even though it's not a right triangle. It kind of looks maybe isosceles a little bit. In terms of these sides look the same, but this angle and that angle and that angle we know have to equal 180. So 3x plus 3x plus x minus 2, right? If I add up all the angles, we know that we should add up to 180 because that is a geometric fact about triangles. So if we start to solve this now, we have an equation. We have 3x and 3x and x. I believe that gives us 7x minus 2 equals 180. If I add 2 to both sides, we get 7x equals 182. And if we divide by 7 on both sides, you see 18 divided by 7 goes in twice. With the remainder of 4, 42 divided by 7 is 6. So I'm getting 26 out of that. All right, and so there's your x value. Of course, you can substitute that in to find the angles. This one's real easy. 26 minus 2, that's a 24-degree angle. And then 3 times 26, whatever the heck that is, that's the size of that angle there. And so there's how you find x. And again, in both these situations, we took advantage of what we know about a triangle, that the sum of all my angles has to equal to 180 to get started. F's a little more challenging, and so let's take a hard look at that. First thing that students often do is they mistakenly say that this angle here corresponds to this angle here, so therefore this must be equal. All right, that is so if you're thinking that when you initially looked at this, please take that thought out of your head. First of all, if you really took a close look, they're not equal. This seems a little bit smaller than that, but the only time corresponding angles are involved is if we have a transversal, something like this up here. And I don't have that. This is not a transversal situation. I don't have any parallel lines. So there's no transversals, so you can't make any assumptions about anything there. All right, so that's the first challenge. Second one is when we look at the labels here, one of the things that's very central to this is not labeled at all, right? This angle is in terms of x. The angle is in terms of x. This guy that is not even part of the triangle that we have there is also related to x. So one of my angles has no name at all. So how about we just go ahead and call it something. We're going to take advantage of that in a moment. Let's go ahead and call that kind of a lonely angle. Let's call it theta. All right, and then here's what we can set up. And what we have here, right, is basically two situations. Situation one, let me go ahead and highlight it in red. Right, if we look at those two angles, they basically form a straight edge, right? A straight angle. So that basically means that this angle here and this mystery angle, that means that these two angles are supplements. So 2x minus 5 plus that theta has to equal 180. So there's an equation that I can build just off of that. However, this isn't enough to find x because there's two unknowns. I don't know what x is, that's what we're trying to find. And theta is this mystery angle that's been not even labeled. We had to do the label ourselves. So we don't have enough information to solve this. However, we have more information from here, right? The other situation is I have a triangle. And what do we know about a triangle? Well, if I took each angle and I added them all up, I would also get 180. So we basically have here is 1/2 x plus 1/2 x plus 15. All right, let me go ahead and put them in parentheses there. So this angle plus that angle plus our mystery angle, right, whatever the heck that is, has to equal 180. And again, we still have not enough information to solve this because this equation has an x and a theta in it. All right. However, if you guys remember from our review week last week, what I now have is a system of equations, right? I have two unknowns, x and theta, and I have two equations. All right, and we could take advantage of that. I think what we did, hopefully you remember from the review exercises, we actually used a substitution. So I'm going to come back up here. How about we solve for our mystery angle? If I subtract 2x and add 5 to both sides, we end up getting that theta is 185 minus 2x, right? That's what we get from that first equation. I can now take that and sub it into the other equation. So we have 1/2 x plus 1/2 x plus 15 plus we now know that theta is 185 minus 2x, and that is what is equal to 180. And so now through that use of substitution, I now have one equation with just one variable in it, and we can solve that. 1/2 x and 1/2 x, well, that's just x. 15 plus 185, I believe that's going to give us 200. Minus 2x equals 180. If we continue to combine like terms, we get a negative x plus 200 equals 180. And we can definitely solve for x. Subtract 200, and we get that negative x equals negative 20. Divide by negative 1, and we just found our value for x. So in this situation, x is equal to 20. Going back and finding angles, half of 20 is 10, so that's a 10-degree angle. Half of 20 is 10 plus 15, that's a 35-degree angle. And then 2 times 20 is 40 minus 5, that's a 35-degree angle, if I did my math right there. All right, so there you go. So hopefully, again, you saw a little bit of a review. Fortunately for us, we didn't see any quadratics, but we definitely, as we worked with our definitions, vertical angles, transversals, triangle situations, we end up with, for the most part, linear equations to solve. And then in this case, we ended up with a system to solve, which we can substitute and turn into a linear equation. So again, previous ideas playing a huge role in things we're trying to learn now. All right, so let me go ahead and pause there for a moment. I'll cut to another video, and we'll continue to take a look at some homework-like problems. See you guys then.